What's going on, math people? We are back and we're talking about the extreme value theorem. Let's jump into some words, some literature, some language. Let's break it down. All right, extreme. When we're talking about extreme, we're talking about something called the extrema. Okay, extrema. And what extrema is, it tells where the function has a maximum and minimum. All right, you can have local extrema and absolute extrema. All right, local extrema and absolute extrema. Extrema and absolute extrema. Local extrema is the stuff that takes in between the points that are in between the absolute extrema. So it's like you have a max, but it's not like the max, like the absolute max. And so, where a max is located. All right, so the way you identify what a max looks like, let me change the color right quick. The max sits on top of hills and whatnot. So your max would be sitting like so. So anytime you have like a little hill looking object, you've identified a max. Now, minimums, you're down in the valley. And at the bottom of the valley, you identify your minimums. All right? And so you can have some crazy looking little squiggly hoopla that goes something like so. And I'm going to curve that on out. You know what I'm saying? All right, so we got this crazy little action going on. So if we go through this, we have on top of a hill right there, there's a max. Here's a minimum. Here's another minimum. And here's another max. And here's another max. So not only are maxes and min found on hills and everything, but whenever you're in a closed interval, like so, the endpoint could actually be a minimum. So let's say we're in this closed interval. We'll call that piece A, and we'll call this piece B. And you see right here, this endpoint is actually the lowest piece on the graph. So that y value would be f of a, and would actually be the minimum value. And then let's say we have some other x value, and we'll call this value x1. And this x value correlates to the highest point on the graph up here. It's higher than the endpoint on this side. So this y value would be f of x1, and that is actually the maximum value. And basically, we just explained the extreme value theorem. The extreme value theorem says if you have a continuous function on a closed interval, we have a continuous function. There are no breaks in that green graph, and the interval AB, then you will be able to identify the absolute extrema. We identify the absolute minimum, which is at f of a, because that's the lowest point on the graph. And we identify the absolute maximum, which is at f of x1, which is the highest point on the graph. All right, so let's jump into some other things, right? Let's say, let me add a little something up in here. Taking from the photos. Oh no, I ain't trying to take no photo. All right, we need to gather a photo from the photo library, and we're gonna roll right here, and we want this. And drop it in the screen. Thank you. All right, done with you. So let's say, all right, it's time for me to actually calculate, go through some functions and calculate what the extrema are. So I'm gonna go here. What I need to do first is bingo, find out what my critical values are, what my critical point is. And in order to do so, to find a critical point, this piece, critical point, is calculated by critical point value. It's calculated by setting f prime of x equal to 0 and solving for x. Anything that makes the first derivative 0 or undefined is considered a critical point value. Alright, we'll get those critical point values, and in order to find the extrema, we will plug in. Up top it says that number 1, it says evaluate. You know, when we start talking, we're like, oh, evaluate just ain't mean to plug in. So we're gonna plug in the critical point values and the endpoint values. Into the original function. Alright, let's get us an example and get the rolling. Alright, let's get us a nice little example. Let's say we have writing in blue. It says find the absolute extrema. Find the absolute extrema. And the absolute extrema, meaning the absolute max or minimum for the function f of x equals -4 over x squared on the closed interval 0.2 to 2.0. Alright, so if we're going to find the absolute extrema, you already know you're going to have to plug in the endpoints into the original problem. So let's go ahead and get that out the way. Let's go ahead and do some plugging in. So we have f of 0.2 equals -4 over 0.2 squared, and that's going to equal something. And let's just play it safe. Playing it safe, we have -4 divided by 0.2 squared. We get -100. -100. F of 2 gives us -4 over 2 squared. That is equal to -1. Alright, so we plugged in the endpoint values, but we also need to plug in the critical point values. So before we can plug in the critical point values, we got to find them. So f prime of x is taking the first derivative of our original function. That gives us 8x to the -3 8x to the negative 3 when you take that first derivative. How did you get that? Okay, the stuff that happened in my brain that didn't show up on the screen. This is the stuff that happened in the brain, in the green. So we have negative 4 times derivative of x to the negative 2 would be negative 2 times x to the negative 3rd power. So, and it produces this guy right here. All right, you're welcome. All right, the other thing over here is up here in the blue. You might want to rewrite this guy so you can see it better. And that's the same thing as saying negative 4x to the negative 2nd. And then you take derivative on that. All right, so now let's keep rolling. Back to the black. So we take the first derivative, set it equal to 0. So we have 8 over x cubed equals 0. There's nothing that's going to make this function 0, but if we do see that 0 would make this undefined. 0 would make this function undefined. X equals 0 gives us some undefined. So the only critical value that we have is x equals 0. So we plug x equals 0 into our original function. And in our original function, what we have is something else that would be undefined with that critical value. So the endpoints themselves produces the absolute max at x equal 2 and the absolute min at x equals 0.2. Cool? You're welcome. All right, my good people. Feel free to ask me questions or whatever. Shoot me a text, shoot me something in the comments, and hey, we'll get you some more.